Alright, so hello, another little tabletop demo of me messing about with my new Arduino board, and I'm just working my way through another one of the really good little Fritzing demos. This is a nice little circuit, a nice little program dealing with pulse width modulation, which sounds a bit scarier than it is. I'll talk about it more in a moment. Basically what's going to happen in a minute when I make it go is that red light there is going to fade up and it's going to fade down. Pulse width modulation, yeah, there's long-winded ways to explain it, but basically digital is either on or off, one of two states obviously. Analog has more possibilities, let's say. Now these pins here, if you want to use them as kind of analog, you can send values of 0 to 255, I think it is, which is obviously a lot more than 0 and 1 on and off. By using a little trick called pulse width modulation, which is basically turning the output on and off very rapidly to create the illusion of analog, if you like. And that's pulse width modulation. If you look on the board, they've got 3, 5, 6, 9, 10 and 11 all have a little squiggle next to them. That means they're capable of that pulse width modulation thing. If I didn't use one of those pins, I could, if I used, for example, pin 4, which can't do pulse width modulation, I could only turn that red LED on and off. But because I'm using one of the pulse width modulation pins, I can do a bit more. I can go from 0 to 255 and fade the light in and out through the program. Right, it's a simple little circuit. Let's have a little look on here. Again, we're on Fritzing here for this. It's easier sometimes to look at these and look at the actual board, but I'll transfer it over. As always, follow the juice. So pin 9 is set as an output. So let me just get my little pointy thing. There it is. So yeah, that's set to output. So electricity is flowing here. So we're on the plus through a little resistor into the positive, the long leg of the LED. Okay, so when juice goes in, it lights, and then back down and flowing back to ground, like so. So it's a very simple little circuit. I'll show you on here without too many bothers. So red, okay, the juice is flowing in there through the resistor, okay, into the positive side of the LED, okay, and then we're negative, flowing back to ground. Where's my finger gone? Over there. It's a simple enough little circuit. The interesting thing is the pulse width modulation end of things, for which I'll jump into the actual sketch. I really like this one. It's a simple little thing. Right, so let's have a look. So first of all, you're setting your LED pin to 9. Okay, 9, as I said, you can see the squiggle next to 9. That means we can do pulse width modulation, which, as I said, it sounds scarier than it is. You're just turning on and off the output very rapidly. Right, so set up pin mode, LED output, obviously. Okay, grand. And then the interesting part. Obviously, it's not interesting, but anyway. So yeah, the loop, the first loop just there. Okay. What have we got? So we're using light value. Often that's set as I, which is just a standard counter. We're going to use light value in here. So it's a for loop. So integer light value equals 0. Okay, so that's our starting. Okay, light value less than or equal to 255. So if that's the case, basically 0 to 255, light value plus plus, which is basically fading up. Plus plus is the same as light value equals light value plus 1. It's a shorthand way of incrementing by 1. It doesn't have to be 1. You could do any number. I'm going to do 1 because that's easy. So what's happening then? Analog write this time. Okay, because we're not, digital write is for your 0 and a 1, but the whole point of doing this is that we're sending 0 to 255 and then back down again. So it's analog write this time. Obviously we're going to the LED pin, and what we're doing is we're taking light value from here, which is counting up basically from 0 to 255. So every time that's done, the value that's counted up is sent into the LED pin as output, and basically all of that basically means the light fades in. And then I put a little delay on there. Actually, in the example on Fritzing, it was I think it's milliseconds. It was a 2 milliseconds. 2 millisecond delay between each of those counts. Not for the entire fade, obviously that'd be really quick. It's between each of those counts. I upped it to 8 just to get a slower fade up and fade down, just so you could see what was going on a little bit better. Right, and then so ground. This is basically going to run when the value is 0 to 255. So that's going to, fade in the light up to its maximum value. To go back down again, very similar bit of code, but this time notice we're going from 255 to 0. Okay, and instead of light value plus plus, which is incrementing by 1, we're decrementing by 1, counting down by 1. So we're going basically 0 to 255, gets written to the pin, and the light comes in. 255 to 0, again gets written to the pin. So fade in, fade out, basically. Fading up, plus plus. Okay, set to LED as analog, fading down, yada yada. It's a nice little little program. It's a good one. So let's see if it works, I suppose. The moment of truth. Okay, come on, little red light. Let's have you up and down again. So 0, 255, 255, 0, 0, 255, 255, 0. Cool. Nice. All right, that's it. Bye.